Hey guys, this is the second video about data and reference variables. If you haven't watched the first one, I suggest you first go watch that one. There'll be a link in the description. What we're gonna do in this one is look at reference variables. I'll explain to you what they are. I'll show you one analogy that hopefully will help you understand it once and for all. And we'll see how reference variables address the limitations of data variables that we looked at in the previous video. And finally, we'll look at the caveats with reference variables that you need to be aware of. Let's dive in. Okay, what is a reference variable? Here I have a definition. A reference variable is a variable whose cell contains a reference to another memory cell. On the left, we have our favorite numbers that we saw in the previous video as well. It is bound to location 1 as before, and it has the values 2, 4, 6. Remember that in the previous video, the values of the array were stored directly in the memory cells where the variable points. 2 was stored in location 1, 4 was stored in location 2, and so on. But now, instead of that, we have a reference, which I denoted by this asterisk. And as I stated before, this reference is a pointer to another memory location, like this. Note that in reality, there'll be more stuff stored here apart from data itself. But we want to keep it simple. I have one example at the end of the video where you'll see more detail. Okay, if reference variables are still confusing to you, let me show you an analogy. If they are not confusing to you, you can still watch the analogy because it's a bit interesting. So here's the analogy. Let's first look at data variables. This is the same guy we had in the last video, and the guy has a pocket, and in the pocket he has Snickers. You can think of the pocket as our memory cell of our variable. On the right you can see our memory, and in this case the Snickers is stored directly in the memory cell. But now what if the guy didn't want to eat his Snickers now? What if he wanted to store it somewhere in a secure location and access it a bit later? So what could happen in this case is he could store it in a safe, in a secure location, and then instead of having the Snickers in his pocket, he'd have a key to the safe. Notice that the pocket is still the same thing, it is still the same object, and in our memory it is still the same memory address and cell. But now, instead of having the Snickers, there is a key. So this key is a reference to another physical location. And if we use the key, we can get the contents. I hope now it's a bit clearer to you. Let me know if the analogy makes sense. Now let's see how reference variables help us address the limitations that we had with data variables. Remember that one of them was static size. One of the things that reference variables allow us to have is dynamic size of values of our variables. Just like before, we have one variable called hair color, and we assign the value black to it. Notice that the variable now is a reference variable because of this reference in its memory cell. The actual string is stored in a different segment of memory. In the next line, we are assigning a longer value to our variable, which is orange. It's one symbol longer. Do you remember how previously we didn't have space to expand in our memory? Guess what? Now what can happen under the hood is this data orange can be placed in a different segment in memory, the one that's free and has space, and then a different reference can be assigned to our variable, like here, 400. Returning to our analogy one more time, imagine our guy wasn't satisfied with just having one Snickers. He wanted to have more Snickers, or Snickerses, I don't know. But his safe was way too small. So our guy decides to buy a new safe and put loads of Snickerses there. And the only thing that he has to do is change the key. In the last video, we saw how data variables were problematic in terms of space efficiency. But this is solved with reference variables. Let's have a look. As before, we have hair color, which is black, and then we have another variable that points to memory address 9, and we copy the value of hair color into it. If we look at the memory layout now, both location 1 and location 9 will hold the same reference value. and it'll point to this memory region. Note that there are some implications of this approach, and we look at them at the end of the video. Now let's do some simplistic calculation to see how much space we saved. Prior to using reference variables, we used 12 memory cells because each cell contains the full copy of the data. And when we started using references, we occupied only 8 cells. Not a big difference. Let's have a better example. Here's a better example. I don't have it in the code, but I have it written here. Let's say we had 100 references and 100 characters. If we didn't use reference variables, then the rough estimate of how many cells would be occupied would be 100,000. But with reference variables, the value is about 1100. The last limitation with data variables that we discussed in the last video was expressing relationships. Let's see how reference variables help us here. As you can see in the drawing here, I've added quite a few arrows. And what these arrows indicate is that there is some piece of data in this space for John, in this space for Steve, for Sophie, for Jessica, that is a reference to another memory segment. A lot of things can be done with references. I'm not going to go into details in this video, but know that even some data structures cannot be expressed and implemented without using references. Lastly, let's look at one caveat with reference variables that you need to know about. Let's look at the codes on the left first. We have a variable called favorite numbers, which is an array, and then we have another variable which is a copy of favorite numbers. The variable favorite numbers points to location 1, and favorite numbers copy points to location 2. Note that after this line was executed, the location 2 has the value 200 star, which is a reference, which is the same as the location 1, as expected. What it points to is actually a bit more complicated than we saw previously, and this is a rough estimate of how this thing could be expressed in memory, but it can be even more complicated. As you can see at location 200, we have metadata about the array. That's not its actual data like 2, 4, and 6. It's data about the array. One of the pieces of this metadata is a reference to the so-called array buffer, where actual data is stored. You can see that in this case, the reference is 400 star, and the actual data is stored here in this segment. Now, what happens when this line is executed? What happens here is that a new element is added to the list. But the variable that's used is the copy. It's not the favorite numbers original variable. But what we have already established, this variable holds the same reference value as this variable, right? And what it means is after this operation is executed, the actual data will be modified and both references will point to the new data. Although, as you can see, the variables themselves will point to the same location, but the array buffer reference will be updated. The last line here, print numbers, favorite numbers, will confirm that favorite numbers content will have changed, even though we acted on the favorite numbers copy. Okay, hopefully it makes sense to you. Exactly how data is stored in memory will depend on how a language is implemented. What happens typically is primitive values such as 5, 5.23, true or false, and so on, they are stored directly in variable memory space. But values like objects, strings, arrays, and so on, they are stored as reference values. Now let's do a recap. Alright, so what have we learned? We've learned that a variable is a name that references a memory cell. I hope you remember it now. We now also know that a variable points only to one address directly. Next, we learned about data variables, which are variables whose cell contain data, partly or fully. They're typically used for primitive values like int, float, boolean, and so on. Data variables have certain problems when it comes to complex data like strings, lists, objects, and so on. These problems are static size, memory footprint, especially serious with lists, objects, and strings that are huge. And the last one is that the data variables do not allow to implement more complex structures, like friend relationships or some data structures. Lastly, in this video, we learned about reference variables. These are variables whose cells contain a reference to another memory cell. What we can do with references is have data that can dynamically grow in various places in memory and be repointed at by the variable. Next, memory footprint is reduced as well. We no longer need to copy data over and over again when we pass data around. And we can also express complex structures like trees or friend relationships. The actual data of a reference variable can be obtained following links leading to the data. But the number of links can be more than one, as we saw on the slides with arrays and array buffers. Lastly, what I want to show you is what you can do with all of this. You can take a screenshot of it, or you can just read it by yourself. But when you start working in a new language, or even the one that you already know, take a moment to understand how it handles variables and memory. You can ask yourself these things. When I copy a variable, am I copying the value itself or just a reference to it? In other words, does it act like a data variable or a reference variable? Does that behavior depend on the data type or on the operator or syntax you use? For example, if you pass a primitive value like 52, or if you pass an object, will the behavior be the same? When you pass something to a function, is it a new value or a shared reference to existing data? If you understand these details, it'll help you avoid subtle bugs, control performance, and predict how your code behaves. Okay guys, that's it about data and reference variables. Leave a comment if you have any questions or feedback. I'll see you in my next video. Bye bye.